Flack math! Give me some math and I'll give you some flack. Flack math!
So today we're going to talk about similar triangles. Similar. Do you guys remember what the word similar means?
I don't think you can see you. Go ahead.
All right. Isn't it like they look similar, but they can be different sizes?
Right. So they have the same shape, but different size. All right. So let me share this screen. So like, for example, every single circle, those are all similar. They have the same shape, but they might just have different size. Like every single square is similar to every other square in the universe. Well, today we're going to talk about similar triangles. So if I drew two triangles that look like this, this is like baby triangle and papa triangle. So the symbol for similarity is this little squiggly. And do you guys remember what, if it's congruent, if they're the same shape and same size, that means congruent. Okay. And what I love about these symbols is that, see how it has an equal sign and a similar sign. So similar is like same shape. Equal sign is like the same dimension. So same size and shape. So I love how this symbol for congruent combines equality and shape, same shape and same dimensions. So that's just cool how that works out. All right, so if you have similar triangles, that means all the angles are the same. So whenever I put an angle and then I put a little tick mark there, that means wherever else you see one tick mark, that's the same measurement. So this would be the same. And then this third angle would be the same. See that? Okay. So that means if this was ABC and this was X, Y, Z, I could say basically the measure of angle A is equal to the measure of angle, not just similar, but equal to. Okay. So these are called corresponding angles. Corresponding angles. So corresponding, the word corresponding means like same position. So like the bottom left angle here is angle A, and the bottom left angle here is angle X. Okay, so angle A corresponds with angle X. Angle B, what does angle B correspond with?
Y.
Angle Y, that's right. And angle C corresponds with angle Z. Okay. Now I could say corresponding sides. So corresponding sides, how do you label a side in a triangle? Can somebody give me an example of two corresponding sides? So I know Adeline knows. Anyone else want to give an answer? Because Adeline is so excited. Is that you, Grady, raising your hand?
Yeah.
All right.
AB and XY.
Yeah, so we would say line segment AB, because remember a line segment has to start and stop with endpoints. So this AB corresponds with side XY, or line segment XY. All right, what about BC? What does BC correspond with? Adeline?
YZ.
All right, good job. And then, of course, our last one is AC corresponds with XZ. All right, now we can say that the angles are congruent. So we can say that angle A is congruent to angle X. Angle B is congruent to angle Y. And angle C is congruent to angle Z. But we can't say that for the sides, right? But we can say that they are proportional. All right, so these are not congruent, but they are proportional. So for example, like this could be twice as long as this. So if AC was 5, then XZ would be 10. If AB was 3, then XY would be 6, right? So you could, they could have a scale factor, but they're definitely proportional. All right. So let me put an example on the board, and so you can kind of see with real life examples here. So here's a triangle. Here is another triangle. So if this is like a 6, 8, 10 triangle, and we know they're similar. So if this was 3, then what are these two values? What would X be? You guys figure that out? I see.
Go ahead.
It would be 4.
Yeah, because look, this looks like half of that, right? So half of 8 would be 4. So someone else tell me what Y is. Shout it out.
Don't go.
5, good job. So far this is pretty easy, right? Well, it's not always going to be that easy. So sometimes it's not like a straight multiply by this or divide by this. You might have to do a little bit of fish method, okay? So let's try some other examples here. Let's try, it's not quite. Okay, so these two are similar. So I'm going to give you some dimensions here, 5, 3, and 6. And then I want to find out what A is, but here's what I know. That's it. So how do I figure out what A is? That looks like a 9. So I'm going to, this is A. So see how I can't just multiply 6 by something to get 10 and then figure that out. I mean, you could, I guess it's like 1.6 repeating, right? Or you could use the fish method. So here's what I would suggest. Let's make a chart. When you don't know, tic-tac-toe. That's what I always say. So I could say like the small triangle, if this is 3, 5, and 6, well, how does it correspond? Well, if A goes with 3, what goes with 6? 10 goes with 6. So look at this. I've got a fish method. I've got 3 over 6 and A over 10. So what's 10 times 3 divided by 6? Adeline knows.
Can I say it?
Yeah.
5.
All right, 5, good. So now we could have figured that out. Like 6 goes in, that's actually 1 2/3. So if I multiply 6 times 1 2/3, I get 10. So 3 times 1 2/3 would give you 5. You could do it that way. That's a little bit more painful, but I think it's easy just to set up a little table here and then fish it out. Okay. That's nice. Now this is cool because you can actually figure out some stuff in real life. And actually, if you guys have seen the movie not Transformers, G.I. Joe. In the movie G.I. Joe, they use this kind of stuff to figure out where, so they see a photo. It's really cool. They see a photograph of somebody, and then they see that person's shadow. And they know when the photograph was taken. And so they determine where they are on the planet using geometry and trigonometry, okay? Because they can tell by the shadow. So let me give you an example here. So this is called indirect measure. So here, this is actually in the book. It says, Sarah looked up and said, I wonder how tall that tree is. Okay, so here's a tree. Yes, you are impressed by my drawing. You're welcome. Okay. I wonder how tall that tree is. So here's what she did. Beth looked down and said, "It's about 25 feet tall." Well, that was her guess. Beth did her knowledge of proportions indirectly to estimate the height of the tree. So here's what happens. So the sun was up here shining, right? So it cast a shadow here, right? Like this. And then here is Beth. No, Beth. What?
I love that. Very beautiful.
How did her name turn to Beth? What? Sarah looked at me.
Yeah, I thought you said Sarah.
Yeah, there's like a typo in the so here's Beth / Sarah's typo or shadow. Okay, this is her creepy looking shadow. Okay, and she measured this, like she measured how far her shadow was, and then she knew how tall she was. So let's say that Sarah or Beth is 5 feet tall. Okay, and then her shadow was like another certain what is it? Let's see here. So she basically measured her shadow, and then let's see her shadows maybe. I'm just making up the problem here now. So let me scoot back here. Yeah, Sarah went bye-bye. It's now Beth. She's taken over Sarah's body. And
Oh, God.
I don't know what happened to Sarah. Maybe, yeah. We don't want to think about what happened to Sarah.
Oh my God.
Too scary. Okay, we made separate. So basically, she made two similar triangles. Okay, so this is the tree. And so she just measured. So if this is Sarah's shadow, it's 5. Actually, let's change this. Let's say Sarah or Beth, right? She's only 4 feet tall.
What the hell? Jeez Louise.
She's young. And let's say that I drew this bad. I'm gonna just make it easy because it's so the shadow looks like this. She's 4 feet tall, and the shadow is 3 feet long. Okay, but then the tree's shadow. Okay, the tree's shadow was, let's say that's 30 feet long. Okay, so how tall is the tree? Because she can't get up to the top of this tree and drop a tape measure, right? That's too dangerous. And she just, I don't know, she ate Sarah, so she's not in the mood for climbing up a tree, right?
Oh my God.
Why does she know the tree?
So she's a little, you're not supposed to like climb trees within 30 minutes after you eat your lunch. So she couldn't.
Or
Shouldn't be. So we can figure this out. So how tall is the tree?
40.
40 feet. Isn't that cool? So you can use this idea of similar triangles to figure out like how tall something is that's crazy tall, right? By looking at the shadows, because they're going to be the similar triangles, right? Because that sun is in the same place, casting the same shadow on the tree as it is on Sarah / Beth, right? So that's a cool way. That's called indirect measure. So you can figure out how to measure something indirectly by using your knowledge of proportions in similar triangles. Okay? All right. So that is lesson 97. We are going to move on, I think, unless there's more to 97. Nope. That's it. So let's move on to lesson 98. Okay, so this is pretty similar to what we just talked about. We're going to talk about scale factor, which is, in our case, the scale factor of this small triangle to the big triangle is just a scale factor of 10. Has anyone ever put together like a model airplane or model car or anything like that?
My little brother put together a model fire truck.
Yes. That's cool. So here's the deal. On those boxes, they have an X factor. Okay, so it might say like X30, which means like if it was a model airplane, that the dimensions of the airplane is the same shape as an actual airplane, but it's a different size. And actually, if it says X30 on the box, that means the airplane is 30 times bigger than the model airplane, or the model is 30 times smaller than the actual airplane. So for example, if the wheel of the airplane, of the landing gear, was 1 inch, then the actual wheel of the airplane would be 30 inches, right? If it's a scale factor of 30. But that's scale factor. So you can do that the same way. You can just multiply each dimension by the scale factor or divide, depending on which way you're going, you multiply or divide by the scale factor. But either way, you can use the fish method to do that as well. So let me just start with an example. So here's a model airplane is built the scale of 1 to 24. So that means it's a scale factor of 24, right? So for example, if the wheel's diameter was 1 inch, then the actual airplane's diameter would be 24 inches, okay? So if the wingspan of the model is 18 inches, okay, so 18-inch wingspan on the model. Then the wingspan of the actual airplane is how many feet? How do you figure that out?
Oh, tic-tac-toe.
Okay, if you don't want to do it that the scale factor way, you can also do it this. So we know the ratio. So here's the model, and here's the no. If the ratio is 1 to 24, and this is the model, and this is the real life airplane. I just put life. I don't know. Then remember your actual number. Where's this 18 go? In the top one or the bottom one? Top one or bottom? Top one. It's the model, right? It's on the model. So then you can just fish it right here. So all you're doing is multiplying by 24. Either way, a scale factor means you can just multiply by the scale factor. And if you're going from the life plane to the model plane, then you just divide by 24. But either way, you can do it this way. So what's 18 times 24? Did you guys figure that out? Was it like 196 or something, like 192 or something? What is it? Figure it out? It's more than that, isn't it?
Nobody has a calculator.
480 minus 48. What is that? 432.
Go ahead, Karen. 432.
All right, cool. 432 inches. And if you wanted it in feet, which is what it asked for, how do you convert 42 inches to feet?
Wait.
Yeah. What's up?
You divide it by 12?
Right. You divide it by 12. Remember, to go from small label to big label, you divide, right? And you go from big label to small label, you multiply. Okay. All right. So divide by 12. And what is that? 36 feet. Ooh, that's bad. Does that sound okay? Is that right? Looks right. That's what the book says.
Oh, you guys are sleepy. Oh, my word.
Okay, so let's try
Anything
another
with
one. Let's-
calculator in math class. Except for Kiara. I know, but this is math class, is it not? Just because Mr. Flack's not here doesn't mean you guys shouldn't be ready for math.
I wasn't ready for math.
You should always be ready for
You're the
math.
only one ready for math.
All right, Sarah. Look, is this the Sarah from the other? All right. So I guess Sarah is molding a model. It's good to see her alive and well. Sarah is molding a model of a car. The scale of the model is 1 to 36. So scale is 1 to 36. So scale factor 36. If the height of the actual car is 4 feet, 6 inches. So this is the height of the actual car is 4 feet 6 inches. So that's not the model. That would be a very large model and wouldn't fit in your living room. Well, it could, but it'd be weird. Okay. So what should the height of the model be? Okay. See if you guys can figure that out. You have a question, Adeline?
Yeah. Did Sarah become a car?
No, Sarah's
Okay.
actually, I mean, you can name the car if you want, but I don't think the car has a name. All right, so so what is the height of the model? So see if you can figure that out. All right, and it looks like we need it in inches because we don't really want to measure models in feet, right? We want to keep it in inches. So you could do it a couple different ways, but I'll let you figure that out and let's see what you get as far as how many inches the height of the car is going to be.
There we go. Oh yeah, I remember.
No, you guys aren't even gonna try in the back there? Yeah, we see that. Would you be lazy if Mr. Flack was sitting here?
Most likely, probably.
Hey, if you're not careful, I'm going to send Beth over and she'll eat you.
I'll be.
Oh, oops, I did it wrong. Hey man, after you do that.
Come on, you guys should be trying this.
Hey, everybody try it.
I'm doing it.
You got it?
Try it with a calculator.
Is it 54?
You know what you are? You are a living, breathing calculator.
Very slow calculator.
I haven't even written it down.
Is that
You're
right?
not gonna-
What'd you get? Did
I
somebody
got-
get it?
I got 54 inches tall.
54 inches tall?
Yeah.
No, I don't think that's right.
Oh, then
What did you do first? What did you do?
I yelled at it. 12 times 4 plus 6.
Okay, so that's good. So that's 54 inches, right?
Yeah.
All right, so then this, so 54 inches. So we could, now we're either gonna multiply or divide by the scale factor. What do you think?
No.
All right, divide.
Ah,
Darn, I did it wrong. No, you divide.
So let's see here. That goes in, blah, blah, blah. All right, and then I'm gonna just add a decimal and a 0. 36 goes in 185 times. So 1.5, and this is inches, right? So 1.5 inches. So this is using scale factor, and sometimes this is easier for students to do than the whole fish method thing. And actually, the next part of the lesson goes through, well, you can just use scale factor whenever you want. Look, let's go back to our similar triangles here and figure out scale factor. Even though it's not a nice number, you can still use it. The only time that it doesn't work real well is when you get repeating decimals. But if you have something like this, 20, 25, well, the scale factor is not obvious, right? But you can figure out what the scale factor is by just dividing. So how do you figure out the scale factor? Well, you can just divide 25 by 20. That goes in one time. Right? And then you bring down a decimal and a 0. So then 20 goes into 52 times. And then bring down another 0, and that goes in 5 times. So 1.25 is your scale factor. All right, so if I was missing one of these, I could just multiply 16 times 1.25, which is 20. Okay, now maybe the fish method would have been better because multiplying by decimals is just kind of a pain, and really you're multiplying a 3-digit number times a 2-digit number. So without a calculator, that's going to take a little bit of time, but whatever, you could do that, you know. But so that's another way you could do it if you wanted to do it. Okay. So the rest of that unit basically just kind of goes through that. So, but here's the deal. When you have let me just check, make sure I'm not missing anything here. Okay. Now, here's the deal. When you find the area, let's go to a more simple thing here. Let me put a couple things on here, and then we'll figure it out. So let's say we've got a rectangle, a 2x3 rectangle. All right, and then we've got a bigger one, 6x9 rectangle. So basically the scale factor is 3, right? You're just multiplying by 3. Now what's the area of this little rectangle here? What is it, Adeline?
Go ahead and say it.
6.
All right, what's the area of this one? Somebody else. What's the area of this big rectangle?
9 times 6.
54.
All right, 54. Now, is this a scale factor of 1 to 3? 6 to 54?
No.
No, this is a scale factor of 9. That's weird, but it kind of makes sense because if you're finding the ratio of the areas, the area is basically the scale factor squared. So this is 1 to 3. This is going to be 1 to 9. What if I wanted to find the volume of these two rectangular prisms here? And let me give you another. Let's say that this is 12 deep and this is 4 deep, right? Still a scale factor of 3 with the individual dimensions. But if I wanted to find the volume, that's going to be 2 times 3 times 4, which is 24. And this is going to be 6 times 9 times 12. Anybody know what that's going to be?
648.
648. Okay, so how does 648 compare to 24? What do you think the scale factor is of the volumes?
I have no clue.
Well, if this is a scale factor of 3, this is a scale factor of 9. Any guesses on what this is going to be a scale factor of?
18.
Close. Well,
Wait,
if this is 3 squared, then this is going to be 3 cubed.
Wait, that would be. I'm thinking. Wait.
Sorry.
Oh, well,
So a scale factor of 3 cubed. So basically, to find the cubic scale factor, and really when you're finding volume, you're finding the measurement in cubes, right? So to find the cubic scale factor, you have to cube the one-dimensional scale factor, okay? Now, this is important to know for other math courses to come, but for now, it's interesting that this happens, okay? So if I had a shape that had a scale factor of 1 to 5, then the area scale factor is going to be 25. That's right. Area scale factor would be 25. And what would the volume scale factor be? You guys know? Think about quarters. 5 times 5 is 25 times another 5. What's 5 quarters?
125.
Yep, $1.25. Okay. So, and really, if you forget this, it's okay. Just do the math and it's not something you have to memorize right now, so don't stress about that. But as you're doing your homework, make sure don't go too fast. Calculate the areas and see what their scale factor is. But, okay, that's about it. So your homework is, and I'm gonna also, we're gonna start reviewing for our final test. And the final test just looks like any normal test. It's not like a final exam, big test. We're gonna start reviewing next week. So if you get your practice test done and come to class with it or have it done before class on next Tuesday, then I'm gonna give you 10 points extra credit on your final test, okay? So, and I'll remind everybody on Thursday as well, but that if you get it done, and I'll make sure I'll make a note of that in Schoology as well. So come to class ready to review for your test that you've already done. So make sure you do that practice test by on or before Tuesday. So when we review it, you have already practiced it, okay? All right, any questions with today's lessons or just what the rest of the year looks like? You guys good? I think yeah.
Anything? No? Well, I guess they're good.
All right, cool. Well, you guys can work the rest of the period. We've got almost a half an hour. All right, so if you want to get some Flack attack points, please do that. It is a new month, so if you want to cash in your free day, you can, but if you need to be respectful of other people trying to work, so let me know or let Mrs. Waite know if you're going to cash in your free day or how many problems you've done by the end of the period, okay? Any questions? You good?
Black math, give me some math and I'll give you some flack. Black math.